With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. Question says that we have to tell which of the following are periodic. So the first function that we have is x minus greatest integer function of x. So let's check whether it is periodic function or not. We know this f of x is equals to x minus greatest integer function. Here this function acts on intervals from one integer to another integer. So if we draw the graph for the same, this is 1, 2, 3 and -1, -2, -3. Then we know since this graph acts interval wise, so let's consider the interval from 0 to 1. Then this function f of x for this values, that is x belonging to this interval, we know greatest integer function will make all the values in this interval equals to 0, and we will have then x minus 0, and x is also varying from 0 to 1. So the graph for the function should be, this should be a straight line graph passing through origin, and it should be void at the point x is equals to 1, and then from 1 it will start from x is equals to 1 till the interval 1 to 2, and similarly this will again 2 to 3, from 2 to 3, and this is void at every point of integer in the interval. So it is void at the limit, that is upper limit. So it is void at 1 for interval 1 to 2, it is void at 2. So and so on, we can see this graph. So we can see that this graph will keep on going in the same way. So this graph is attaining its values again and again. That is, the values that the graph is taking are from 0 to 1. The graph is taking the value from 0 to 1 only, and we know that the maximum value of the graph of the function x minus greatest integer function x should be the value 1. So we can say that fx is taking values from 0 to 1, and it is repeating its values in the period of every consecutive integer interval. That is, if there is an integer n and we make the another integer, that will be n plus 1. So it is, the function is attaining its values 0 to 1 in the interval n to n plus 1, where n belongs to the integer. So function number 1 is periodic. Now let's check f of x is equals to x. So the function f of x is equals to x, we know its graph. Let's draw the graph for the same. This is a straight line graph passing through origin, and from the graph we can see that there is no value in the domain x for which the function is attaining its value again. In fact, we can see that corresponding to each x, the function is attaining a distinct value every time. So we can say that f of x is equals to x is not periodic because it is not attaining the same values in some interval. So we can say f of x is equals to x is not a periodic function. Now look at to the function 2 tan 1 by 2 x minus 5. So the function here is 2 times tan 1 by 2 x minus 5. So we know about the graph of tan function that it takes the values when x is pi by 2, or we can say when x is n pi by 2, then 10x becomes not defined. That is, tan function becomes not defined when x is n pi by 2, where n belongs to integer. Now we have defined the tan angle that we have given is half of x minus pi. Now we have to look for the values of x where half into x minus pi will become n pi by 2. That is a multiple of pi by 2. So we know x should be any multiple, x should be any multiple of 2 n pi. That is, if we put n is equals to 1, let's say, so this will become 2 pi. 2 pi minus pi will give pi, and we will have the angle tan of pi by 2 that will become not defined. This is what we know about the graph for tan function. So we know that this function that we have given is becoming not defined when x is 2n pi. That is at x is equals to 2n pi, this function will attain y asymptotes, and if we put x is equals to n pi, then the value of tan will become pi minus pi, that will be 0, that is tan 0, that is 1. So we have got some of the values. We can plot the graph for the function. Now we know, let's say this is the point pi and this is 2 pi. Here it is minus pi, it is minus 2 pi, and this is the point 0. So if the function is attaining 0 value at pi, and this is the function is attaining the value 0 here, and here the function is not defined. So if the function here is 0, so that means the function is passing through this point, and the y asymptote is lying at 2 pi and at the 0, because 2 and pi can be written as 0 into pi also. So this is the graph would look like this one. Similarly, this graph will have asymptote here, which will pass through minus pi, and then again it will have minus 2 pi. Similarly, we can plot the graph for 3 pi, 4 pi. This will pass through 3 pi and have y asymptote parallel to 4 pi, and here it is parallel to 2 pi. Now we can draw the graph similarly. So we can see here that the function f of x is taking the values, the range set for the f of x is minus infinity to plus infinity, because this graph is going beyond this. It is going to minus infinity in downward direction and going towards plus infinity in the upward direction. We can see that the value of this function is attaining by f of x in every interval from 2n pi to 2n pi plus 2 pi interval. So this is taking the values from 0 to 2 pi, then again it takes the values from 2 pi to 4 pi, and similarly here it is taking the values from minus 2 pi to 0. So we can say that the period after which the function 2 of tan 1 by 2 x minus pi is attaining its values is this period. That means tan function that we have given, it is also periodic. So option number 1 and option number 2 are examples of periodic function. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.